Chapter 5, estimating our logistic when I0 is 2 magnitudes less than K. These two less thans, you can take that to mean really less than. This is quite often used in physical science. It's worth mentioning here. Here's a precise definition. I0 is less than K means that I0 is less than 1% of K, or 0.01 times K. And in that case, you can actually show that the exponential growth rate and the logistic growth rate agree to three significant figures. We'll talk about significant figures in a minute, if you don't already know that. So for example, suppose we have an infectable population or a susceptible population of 10,000, and we have 5 initial infections. And let's suppose I is doubling every 4 days. 1% of K, 1% of this number is 0.01 times 10,000, which is 100. You can move the decimal over 2 places. And 5 is indeed less than or equal to 100. Okay, so I0 is really less than K. You could use that term if you want. Given that, here's an interesting formula. You can calculate the exponential growth rate by doing ln of 2 divided by the doubling period. We can derive that actually using our exponential model. And so in this case, you can just go ahead and calculate RE, ln of 2 over 4, which ends up being 0.1733. This fourth decimal place is rounded. So, very quick calculation, our logistic growth rate we can take to be 0.173. So it's a very quick way to get that without wading through all the logistic calculations. So our model is this. That's a familiar logistic model. You can substitute all the numbers, 10,000 for K, 5 for I0 here and here. Put the constant there, the growth constant there, and there we have it. There's a logistic growth model. As far as significant figures are concerned, here's a simple trick. Let me erase this really quickly. There are really two significant figure rules. If we have a decimal point, like for instance 0.005209, but it turns out we ignore zeros on the left. And so we have four significant figures. If we have without a decimal point, so for instance 52,000, ignore the zeros on the right, and we have two significant figures. There's two rules. A lot of chemistry books will state 4 or 5 rules, and it takes you a long time to navigate your way through that. This is a very simple way to figure it out. It's instantly teachable in a couple of minutes. It's a rule I came up with. You can apply that to all cases. This zero is significant. It has to be the consecutive zeros on the left, consecutive zeros on the right. And so, for instance, if we had, for instance, 502,000 or 000, we'd have 3 significant figures. Now, if you have 502,000 point, that fits this first rule. And And so we ignore any zeros on the left. There are no zeros on the left, so all digits are significant. 1, 2, 3, 4, 5, 6. That fits that rule. So very simple rule, worth mentioning. So, okay, that's all for chapter 5.